All right, it's time to get ready for our final exam for the semester. And so number one asks, what is the domain and range of this equation? And so this, because the squared right there, this is a quadratic, which makes that u. And so if we wanted to sketch a graph real quick, it goes to the right 3 and up 9. So somewhere around here, and because of this negative, it's going in the downward direction. And so something like that. And so this point is at 3, 9. And so for my domain, quadratics is always all real numbers. And then my range, the lowest it goes is all the way down to negative infinity. The highest it goes is 9. Number two, what is the domain and range of this function? So again, I need to find the domain and range. For this, I know it, because of the squared, it is a quadratic, but I don't know where the vertex is. So I'm going to come out here to the side, and we're going to do the negative b over 2a to find the x value. And so negative 4 is going to be positive 4 over 2 times 2, which is going to be 4, so that's 1. And then we'll plug into the 1 to find the y value. And so I'll just use my calculator for it. We'll have 2 times 1 squared minus 4 times 1 minus 10. And it gets negative 12. And so I put 2, I've just plugged in the 1. 1 squared minus 4 times 1 minus 10 to get the negative 12. And so we're going to start at 1, negative 12 down here. Because it's positive, it's going to be up, an upward shaped U. My domain, again, is all real numbers. My range, the bottom is negative 12, all the way up to the top, which is infinity. Number 3, look at the function shown to the left. What is the parent function of this graph? So this one starts right here and goes up and to the right. That's a square root graph. Which is y equals square root of x is the parent function. Find the vertex of this equation, just like we did on number 2 earlier. We're going to do the negative b over 2a, which is going to be negative 14 over 2 times 1, which is going to be negative 7. And then we'll take that negative 7 and plug it into our calculator. Oh, not 52, 57. All right, and so we'll just plug that in. So we're going to have make sure you put in negative 7 in parentheses squared on the outside, plus 14 times negative 7 plus 57 gets 8. Find the inverse of each of the following functions. So for a, I'm going to go ahead first switch the x and y. So x equals 4y minus 3. And we want to solve for y. So we're going to add the 3 over. X plus 3 equals 4y. And then we'll divide by 4. So y equals x plus 3 over 4. That could also be written, divide each of them by 4, 1/4 x plus 3/4. So there's A. Then for B, we'll do the same process. We're going to have x equals y minus 5 over 4. And so the first step, this 4 is what we need to get rid of first. We're going to multiply both sides by 4. So 4x equals y minus 5. And then we'll add the 5 over. 4x plus 5 equals y. C, we'll again switch to x and y. So x equals y plus 11. And we'll subtract 11. X minus 11 equals y. And D. X equals y plus 7 over 3. We'll multiply the 3 on both sides, so 3x equals y plus 7, and then we'll subtract the 7 over. 3x minus 7 equals y. And so there's my A, my B, my C, and my D. Given the discrete function shown in the graph, what is the domain and range? So for this one, since it's discrete, it doesn't contain all the points in between these coordinates. So don't connect the dots. It's just gonna be this, then this, then this, then this. We're just gonna list all the values. So for my x's, my domain, we're just gonna go left to right. So we have 1, and then 2, and then 3, and then 4, and then 5, and then 6. For my range, we'll do the same thing. We're just gonna go bottom to top. So my bottom point is negative 1, and then 0, and then 1, and then 2, and then 3, and then all the way up to 6. Number 7, what are the factors of 3x squared plus 7x minus 20? And so we got to factor this. I'm going to 3 times, we got a times c on top, which is 3 times negative 20. So we got negative 60 on top and 7 on bottom. And we got to try to think, okay, what multiplies a 60? And since we're going to negative 60, we know it's going to be a positive and a negative. And so since it's a positive and negative, what subtracts to 7? And so I know it's going to be 12 and 5. Since it's a positive, we're going to have 12 on as a positive, and then 5 is the negative. 12 minus 5 is 7. 12 times negative 5 is negative 60. My a value is 3, so we're going to divide by the 3. And when we simplify this, this becomes 4 over 1. This one can't simplify. So my two factors are going to be 1x plus 4 and 3x minus 5. What is the domain and range of the quadratic function? So we're doing another quadratic function. For this one, could be standard form or it could be vertex form because there's no x. And so for this one's going to go up 4. There's no left or right movement. And so it's going to go up 4 right here. And because it's negative, it's going to go in the downward direction. So something like this. And if you wanted to as well, you can always graph it in your calculator to see what it looks like. We can go in our y equals negative 3x squared plus 4, graph it, and it looks similar to what I drew as well. And so looking at this graph, my domain again for a quadratic is always all real numbers. It goes forever left, forever right. My range, it goes all the way down to negative infinity, and it goes up right here to 4. List all transformations. So this negative in the front is going to reflect it over the x-axis. And so just to kind of label what I'm doing, that's the negative. And then the x plus 2 is going left 2. And then the minus 7 is going, so I'll put colons right here, is going down 7. The squared, it doesn't do any transformation. That just tells me it's a quadratic function. Which of the following is a solution to this? So is a solution. So I'm looking for ones that are true. And so for this one, we're just going to plug in x's and y's. So for letter A, we'll plug in 2 for y, and we'll plug in 3 for x, and we'll see if this is true. And so is 2 greater than, that's 9 minus 5, which is 4, is 2 greater than 4? Nope. So A is not a good solution. And then for B, we'll do the same thing. We're going to plug in 0 for the y is greater than negative 1 and parentheses squared minus 5. So that becomes 1 minus 5, which is negative 4. Is 0 greater than negative 4? Yes, it is. So I'm going to circle B. For this one, we could potentially have more than one answer, so let's go ahead and check the rest of them. For C, is 5 greater than 5 squared minus 5? So that's 25. Is 5 greater than 20? Well, no. And so it's not C. And then we'll try D as well. Is negative 5 greater than 0 minus 5? So that's 0 squared, but that's still 0, greater than negative 5. Is negative 5 greater than negative 5? No, they're equal to, and so B is my only answer. The BHS Theater collected $1,415 for 375 tickets sold at their school play. If adult tickets were $5 and student tickets were $3, how many of each were sold? So our two variables are adults and students. And so we know there are 375 total tickets sold. So A plus S equals 375. And then now with the money involved, we have 5A, because every adult ticket was $5, plus 3S. Every student ticket was $3, equals the total amount of money they made, $1,415. And so now we'll go into our calculator and we'll use the matrix. You could also do substitution, elimination. There's multiple ways to solve this one, but the fastest way is going to be with the calculator doing matrix. So I'm going to go second matrix. We're going to edit it. This one's a 2 by 3. And then we put in all of our coefficients. So 1, 1, and then 375, 5, 3, 1415. And then we're going to go second mode to quit out. Go back to the matrix. We're going to go to math, and we're going to do the RREF. That's the reduced row echelon form of matrix A. And so the adult is the first one. Since I had adults first, that's my first one. Adults is 145. And my students were 230. And how many of each were sold? We answered the question. Devin went to the outlet mall. Jeans were on sale for $25 a pair, shirts for $15, hats for $10. She spent a total of $215 and she bought 14 items. She also bought 3 times the number of shirts as she did hats. Write a system of equations that would represent the situation. And so we don't have to solve on this one. It just wants us to write the system of equations below. And so the first one we can do with money. So 25J plus 15S plus 10H is equal to $215. And then she bought 14 items, so the number of jeans plus the number of shirts plus the number of hats is equal to 14. And then the last equation, this one's the kind of tricky one. She also bought 3 times the number of shirts as she did hats, which means she bought more shirts. And so my shirts is actually going to be equal to 3H. For every 1 hat, we're multiplying by 3 to get the number of shirts. And so if you want to, you could plug in a number. Like if I bought 2 hats, I would multiply by 3, 6 shirts. Is that what we want? 3 times the number of shirts is hats? Yep, that's what we want. And so we'll make it matrix ready by moving one of these over. It doesn't matter which one. And so I'll put S and I'll subtract the 3H over is equal to 0. So there's my system of equations. I could plug that in to get the answer, but I don't need to on this one. One thing I didn't do, this said X is the number of jeans, Y is the number of shirts, Z is the number of hats. So it'd be the same thing. It would just be an X everywhere you have the J, Y everywhere you have an S, and a Z everywhere you have the H. But same thing. All right. Number 13, solve the equation. And so you can solve it by factoring or quadratic. I'll do both just so you can see both of them. But using factoring, I would think, okay, A times C is 12. 7's on bottom. What 2 numbers multiply to 12 and add to 7? This would be 3 and 4. So x plus 3, x plus 4 is equal to 0. And then we'll set each equal to 0 to solve. So if x plus 3 equals 0, we'll move the 3 over with subtraction. And we'll move the 4 over with subtraction. If you did quadratic formula, we would have negative b, I'll write the formula, plus or minus square root of b squared minus 4ac all over 2a. So negative 7 plus or minus square root of 7 squared minus 4 times 1 times 12 all over 2 times 1. So negative 7 plus or minus, if we were to put this in the calculator, 7 squared minus 4 times 1 times 12, you get 1 over 2. Square root of 1 is 1, so we're going to have negative 7 plus or minus 1 over 2. And so negative 7 plus 1 is negative, and so I'll go ahead and branch it. So negative 7 plus 1 is negative 6 over 2 is negative 3. Negative 7 minus 1 is negative 8, divided by 2 is negative 4. So either way, we get negative 3 and negative 4. What would be the parent function of this? Well, these bars right here mean absolute value, so it's the absolute value graph, which is y equals absolute value of x. Graph the system of inequalities, and so to graph it, we'll go ahead and get the y by itself. So for the first one, we'll subtract 2x over, so negative y is less than or equal to negative 2x plus 3. And then we'll divide by negative 1, so y, when I divide by negative 1, I have to flip the inequality greater than or equal to positive 2x minus 3. And so we're going to go down to negative 3, 1, 2, 3. We've got a positive 2 slope, 1, 2, 1, 1, 2, 1, 1, 2, 1. Because it has the equals, it's going to be a solid line. And because it's greater, we would shade above. So I'm just going to kind of do a light shading up there just to know where it would be. For my other one, we'll subtract 5x over. So y is greater than negative 5x plus 8. So we're going to start at 8. And we're going to go down 5, 1, 2, 3, 4, 5 over 1. Down 5, 1, 2, 3, 4, 5 over 1. This one's going to be a dotted line. And this one's greater than, which means we're going to shade above. And the common shading's right here in this area. Solve for x in the following, the absolute value inequality. And so first step is get the absolute value by itself, which it is, and then we're going to split it. We're going to set this inside 2x minus 3 is less than 13, but also 2x minus 3. We're going to flip the inequality greater than negative 13. And then we'll solve for each of them. So we'll add 3 over, 2x is less than 16, divide by 2, x is less than 8. On this side, we'll add 3 over, 2x is greater than negative 10, divide by 2, x is greater than negative 5. And so this is actually an and statement, which you could write it, x is greater than negative 5, less than 8. Either one of these would work. Graph the equation. This one is a quadratic, and so we're going to start by going left 2 and down 7. And then our normal points, just as a reminder, is from the vertex. I usually go right 1 and up 1 because 1 squared is 1, right 2 and up 4 because 2 squared is 4. But on this one, we're multiplying by 2 because we have that vertical stretch. And so we're going to go up 2 and we're going to go up 8. So right 1 up 2. Right 2 up 8, 1, 2, 3, 4. And same thing on the left side. All right, number 18. Write the equation that is the translation of this to the right 4 units. So we're doing a square root graph. We're going to go to the right 4 units, so x minus 4, and down 9 minus 9. There were 310 people in attendance at Hairspray this last weekend. There were 4 times as many students as there were adults. Right, this is an equation that represents this equation. Solve for the number of adults and students. So adults plus students equals 310. 4 times as many students, so more students than adults. So for every 1 adult, we're multiplying by 4 to get the number of students. So 4 times as many students as adults. So every 1 adult, we multiply by 4. So now I'll just subtract the s over. So 4a minus s equals 0. And now we're ready to solve. And so I'll go into my calculator. We'll go back to the matrix. Put in all my coefficients. So 1, 1, 3, 10. 4, negative 1, 0. We're going to quit, go back into matrix. We're going to calculate the RREF of matrix A. And so my adults is 62, and my students is 248. So all the following of the system. So just make sure everything's in order. X, Y, Z, answer, X, Y, Z, answer, X, Y, Z, answer. If anything wasn't in order, we'd have to rearrange it. This one's good to go. And so this one's a 3 by 4. I got 3, 2, negative 1, 11, 2, negative 1, 2, negative 3, 1, 3, negative 1, 8. And then we want to do same thing. We want to do the RREF of matrix A. And so my X is 2, my Y is 1, my Z is negative 3. Number 21, what is the value of x for the solution to the following system of equations? So on this one, I just want the x value. You could do this graphing, you could do it a substitution. I'm going to go ahead and do matrix again. So I'm going to move the 2x over to be negative 2x plus y is equal to 15. That's when I'm going to add the 1/3 x over. So 1/3 x plus y is equal to 1. This one's back to a 2 by 3. We have negative 2, 1, 15. We have 1/3, 1, and 1. And the RREF of matrix A. So x is negative 6, y is 3. Again, it just wanted the value of x. So that's my answer. Solve the following system of equations. So let's make sure everything's in order. This one's got a quadratic. So on this one, we want to solve for y first, and then we'll set them equal to each other, and then set equal. So on this one, y is equal to, we'll move the x squared over, x squared plus 2x minus 5. On this one, we'll subtract 15 over to get 13x minus 15. And then we'll set these two boxes equal to each other. So x squared plus 2x minus 5 is equal to 13x minus 15. We want to get it set equal to 0. And so we'll subtract 13x over, and 2 minus 13 would be negative 11x. We'll add the 15 over, negative 5 plus 15 is going to be plus 10. And then you could either factor it, or you do quadratic formula. I'm going to go ahead and factor it. So we're going to have 10 on top, negative 11 on bottom, which would be negative 10 and negative 1. And so it's going to be x minus 10 and x minus 1. Set equal to 0, x equals 10 and 1. Number 23, write the equation of the square root function. One thing I do want to go back to on 22, if you wanted to, you could find the y value by just plugging it in. And so for one of the coordinates, if I were to plug in 10 into here, that's going to be 10 times, so I'll just plug it in, 13 times 10, and then minus 15 is going to be 115. And then for the other one, we could plug in the 1, so 13 times 1 minus 15 would get me negative 2. And so there are the two coordinates, the x and the y value. But, all right, continuing, number 23, write the equation of the square root function that has been vertically stretched by a factor of 3, so that's going to go in the front, shifted to the right 5 units, and shifted down 2 units. Write the equation of a parabola that has been shifted left 2 units, parabola's going to have the squared, up 5. How do you find the equation of the inverse? You switch x and y, solve for y. Over what line do inverses reflect? That's y equals x. What is the sum of x and z for the solution? So let's make sure everything's in order. X, y, we're missing z, x, y, z, x, y, z. All right, we're good to go. And so in our matrix, we're going to go in the matrix, edit. This one's a 3 by 4. 3, 2, 0, 13, 3, 2, 1, 13, 2, 1, 3, 9. And then we'd want to do the RREF of matrix A. So on this one we get x is 5, y is negative 1, z is 0. Sum means addition, so for x and z, 5 plus 0 is 5. Solve for x in the following. And so first I want to isolate the absolute value. So 3, absolute value of 5x plus 4 is equal to, we'll add the 6 over to get 24. Then we'll divide by 3. So 5x plus 4 is equal to 8. And now we'll split it. 5x plus 4 equals 8. 5x plus 4 equals negative 8, and then we'll solve for both of them. And so for this first one, we'll subtract 4, 5x equals 4, divide by 5, x equals 4 fifths. Subtract 4, 5x equals negative 12, divide by 5, x equals negative 12 fifths. And if you wanted to, you can always check your work. And so one way we can always do this is I can store in numbers for x. So I can put in 4 divided by 5 and store it in for x. And so now x is going to be 4 fifths. And just plug it in as it is. So 3, absolute value, 5x plus 4 minus 6. And see, does it equal 18? Yes, we got it right. Now I can do the same thing with the other one, negative 12 divided by 5, store it in for x. And I'll just copy and paste this equation down. It equals 18, so both of them check. Transformations. So the negative is the reflect over x. The 1/5 is a vertical compression. The x plus 2 is left 2, and plus 4 is up 4. Find the inverse. You could solve for y first, but there's no need to. Just go ahead and switch your x and y. So 4x equals y plus 4, and then we'll subtract 4 over. 4x minus 4 equals y. List the domain and range. Again, we have a quadratic, and so we know the domain is going to be all real numbers. And then for the range, this is going left 3 and down 7. And so left 3, down 7, somewhere in this area, it's negative, so it's going down. And so that's negative 3, negative 7. And so my range is going to go as low as negative infinity and as high as negative 7. solve for x in the following. So we want to first get it set equal to 0, so 2x squared plus 3x minus 5 equals 0. And then we'll see if it factors first. So we're going to have negative 10 on top because that's 2 times negative 5, 3 on bottom. And we're going to have 5 and negative 2. And so that's going to be 2x plus 5 and x minus 1 equals 0. And so x equals, if I set this equal to 0, we're going to subtract 5 and then divide by 2. So negative 5 halves, add 1. Those are my two answers. What are the roots of the parabola of this equation? So the roots are my x-intercepts. The solutions, we're just going to put 0 in for y and solve for x. And here's one thing that's nice. It's the same equation that we just did. And so I don't have to do it again. My x equals negative 5 halves and 1. Write the equation in standard form, which just means I need to FOIL this. And so I'm going to multiply everything together. So y equals x times x is x squared, x times 1 is x, negative 5x, and then negative 5. We'll combine like terms in the middle, x squared minus 4x minus 5. That's my answer. And last one, graph this equation. This is a quadratic, and so I need to first off find what is the vertex, and so I'm going to do the negative b over 2a, which is negative 8 over 2 times negative 1, which is going to be negative 2, so that's going to be 4. And then we'll plug in the 4. So negative 4 squared plus 8 times 4 minus 14 gets 2. 1, 2, 3, 4, 1, 2. It is negative, which means it's going to go down. So we're going to go over 1 instead of up. We're going to go down 1, over 2, down 4. 1, 2, 3, 4. All right, that finishes off our semester review. If you have any questions, make sure to let me know, and good luck on this final.